Hello everyone, in this lecture we will discuss about design strength of fillet weld. So you can refer clause number 10.5.7.1.1 for the design strength of fillet weld. So design strength of fillet weld can be calculated by design stress into area of weld okay. So here the design strength of fillet weld means the load carrying capacity of the joint. Okay, so the load is calculated as stress into area. Okay, so here the design stress is Fu divided by √3 into gamma mw into area of weld. Okay, so area of weld is the multiplication of effective length of weld into effective throat thickness. Okay, so this is the formula to calculate the design strength of fillet weld. Okay, so here Fu is the ultimate stress of weld or material so generally Fu is the minimum of the ultimate stress of weld and the ultimate stress of material, but generally the material for the weld and the steel member is same. So Fu is the ultimate stress of weld or the member. Okay, the next come to gamma mw. Gamma mw is the partial factor of safety for weld. Okay, so for soap fabrication that value is 1.25 and for field fabrication the value is 1.5. Then next come to effective length. Okay, so in the last lecture I have discussed that effective length is the length which generally considered for the load transmission in the design. Okay, and that can be calculated by total length of weld minus the end return. Okay, then the effective throat thickness, and the effective throat thickness can be calculated by K into size of weld. Okay, so K the value of K you can get from table number 22, that depends upon the angle between two fusion faces. Okay, and size of weld is equal to leg size length. Okay, so here effective throat thickness is called K into S. Okay, and this value you can get from the table number 22, but generally in most of cases the fusion faces are in 90 degree. So generally we take the value of K as 0.7. Okay, and this size of weld is equal to the leg size. Okay, and effective length of weld is the total length of weld minus end return. Okay, so if in the question total length of weld will be given, then just deduct the end written, then calculate the effective length. Okay. If in the diagram you can easily calculate the effective length of the weld, then no need to deduct the end written. Okay. So it will be clear when you will solve the question. Okay. So in case of bolted connection, we have learned about the reduction factor. Okay. So here also in case of welded connection, there is reduction factor. Okay. So the reduction factor for long joint. Okay. So if the length of joint, okay, if the length of joint will greater than, if the length of joint will be greater than 150 into throat thickness, then the strength of the design strength of the fillet weld will be reduced. Okay. So if the length of joint will be greater than 150 into effective throat thickness, then the design strength of fillet weld will be reduced. So for that we need to calculate the reduction factor, that is BTW. Okay. And this reduction factor you can calculate by the formula, that is 1.2 minus 0.2 Lj divided by 150 into effective throat thickness, which must be less than equal to 1. Okay. So for the reduction factor you can refer the clause number 10.5.7.3. Okay. So if the length of joint will be greater than 150 into throat thickness, then in this condition we will calculate this reduction factor, that is 1.2 minus 0.2 Lj divided by 150 into throat thickness. Okay. So here this Lj is the length of joint, length of joint in direction of force transfer. Okay. So means let these two members are connected by fillet weld. Okay. So if in this direction the force will transfer, okay, if in this horizontal direction the force will transfer, then in this direction we will consider the length of joint. Okay. We will consider the length of weld in the direction of the force transfer, and here Tt is the throat thickness. Okay. So in this condition, the strength of the fillet weld will be reduced. So after calculating this reduction factor, we will multiply this reduction factor in this formula. Okay. Then we will calculate the design strength of the weld. Okay. So now this formula will be applicable only in this condition. Okay. So when this condition will happen, you will calculate the design strength of the weld by this formula. Okay. Otherwise this value is 1. Okay. Otherwise this value is 1. Okay. So this much all about to discuss. In the next lecture we will solve an analytical problem related to this design strength of fillet weld. Okay, thank you.